Okay. Maggie, how are you? Thank you. Thank you. Hello. Welcome. So, at the end of the lesson yesterday, I'm sorry, at the end of the activity yesterday, we asked how far had a particle traveled in the first 6 seconds. And there was definitely this glaze that came over people's eyes of like, oh my gosh, I don't know if I can remember how to do that. So your last lesson today, your last lesson is a review of that. So as a teacher, I've prepared for that. You see, when we went through this, the fact is I know that we kind of looked at these questions to start out, okay? But the fact is we want to add a couple more questions in at this point because here's the thing. I kind of made an example during link crew this morning, but the fact is when I was studying a language, I would keep a list of uh, vocabulary. Anybody do that for foreign language? You got a list of vocab words you need to study, right? Do you ever take that list and after you're done with that test, you just throw that list away? You're like, okay, we don't need to know the verb hablar anymore. Bailey's saying no. You add on to the list, correct? Picture that, folks. We are adding on to the list. This piece that we're talking about right now, the reason why we bring it back up, we'll actually bring it back up again chapter 5, and then we'll bring it back up again before the AP test, because just about every single AP exam from back to 1965 has this type of question as one of the free response questions. Yes, half of your test will be multiple choice. The other half is 6 problems that are free response. And this would be an example of a free response type question worth 9 points. Okay? So, definitely one we want to keep at the forefront of our brain. Let's see what we remember, what we don't. The equation of motion particle is given by S, where is it measured in meters and T is in seconds. What is the velocity at time T? What do I do? Derivative. Velocity is the derivative of position. Very good. So V of T is equal to what? 18T minus 3T squared. Excellent. Now we introduce the second piece. It's no big deal. It's acceleration. Anybody's taken physics? Do you know how acceleration compares to velocity or position? Acceleration is the rate of change of velocity. So acceleration is the second derivative. What is the derivative of 18t minus 3t squared? 18 minus 6t. Is everybody okay with that? Are there any points of confusion? So what I'm going to do now is I'm going to answer these next 2 questions. The question is, when is the velocity positive? I'm going to actually look at the graph of the velocity function. I can see it's a parabola, right side up or upside down. Upside down, I'm going to factor out a 3t, and when I do, I get 6 minus t. Everybody good with that? And I'm going to create the graph. It goes through 0 and 6. Can somebody tell me when is the velocity positive? Very good. Now I'm going to determine when the acceleration is positive. If this is the velocity function and it's quadratic, the acceleration function or the derivative will just be a line, correct? And the line is 18 minus 6t. If you found out where it crosses the x-axis, we have 6 times 3 minus t. You're good with that? So it's a line with a slope of -6. It looks like it passes through 3. Are you okay with that? Good. When is the acceleration positive then? 0 to 3. There is, so that the acceleration is the second derivative. There's a third derivative, and we call it the jerk. It's the, yeah. We are not going to need to know that. I don't see the app, your book addresses it. I don't see the AP exam address in it. So the new piece, so this is all pretty straightforward, right? So we're going to get to this last question, which is what is the distance the particles travel first 8 seconds? Because I know that that's something that ties in what we learned first, right? But this is the new question, and this is what we have to wrap our brain around. And it's not too challenging, but let's just make sure we understand. The only time this year. Okay. But I know the first time I taught it, I did not really explain it in that way, and people remain confused for the rest of the year. When we come back to this, you guys will remember same sign speeding up, opposite sign slowing down. The question is, when is the particle speeding up? Let's look. We start at time 0. Is the acceleration and the velocity positive here? Yes. Are they both positive here? No. So they are the same sign between what? 0 and 3, union with, when do they become the same sign again? 6 to infinity. You guys see that? When is the particle slowing down? When they are opposite signs. So here I'm negative, here I'm positive. So from 3 to 6. That's the piece we want to focus on adding today. Looking at the graph and determining when they're positive and when they're negative, when they're overlapping. What is the distance the particle traveled over the course of 8 seconds? 8 seconds. Okay, that's what I want to do now. So do you remember how we determine this piece? We consider the start. When else? When it changes and when it ends. Start is at time equals 0. End is at time equals 8. Can anybody look at my graph and tell me when does the particle change direction? 3 is a good answer. It is not correct. 6. A particle changes direction when the velocity changes sign. Velocity changes from positive to negative at 6. It's when velocity changes that the particle changes direction. Got that? Those are the times I need to consider. I want to figure out the position. How do I calculate the position at time 0? I plug 0 into the position function. Plug in 0, what do you get? I get 0. Plug in 6. Oh boy, I need my calculator. Okay, what do we got? 9 times, is it 6 squared? Minus 6 to the third. And we get 108. After that, I go ahead and I change the 6 to 8. 8 and 8. And I get 64. So if I draw a picture motioning this, I start at 0, I go over to 108, and I go back to 64. So if you want to go total distance traveled, and a lot of you actually figured this out yesterday working through this type of problem, which was great. So like I go 108, and I add on to that whatever 108 minus 64 is. 108 minus 64. I get that, and I add 108 to it. 152 is my total distance traveled. Yes? Good. You're going to pause. You're going to start this problem on your assignment.